Alrighty, we are recording. So, I have a handful of people in here, it looks like so far. Otherwise, Streamlabs is very slow this morning. Could be a possibility as well. Anyway, we can get going. Good morning to those of you that are here and those of you that drop by a little bit later. So we finally got through basic requirements. What we're going to cover today is we're actually going to go through some of your in-class assignment submissions. So we're going to talk about your requirements that you all put up. And we have some things to talk about, which is good. Constructive criticism is always a good thing, right? Those are graded, so if you see a 0 or no grade in your in-class assignment, that means I didn't get it or I didn't see your name, so let me know if that was the case. I still have a very hard time trusting Blackboard. I'm going to work on getting your other homeworks graded this weekend too, so you should be getting actual grades, not just zeros there. So, Section 2. I collated the majority of your what you submitted, and overall they're pretty good, so they're definitely good stabs at it. And obviously you haven't had formal training with requirements engineering. This is more of an exercise to see kind of what you all understand is what an NFR and what an FR is. So I kind of wanted to go through these and just talk about them. Right, I didn't grade you on the particulars here. I just wanted you to go through the exercise of doing it. So again, non-functionals, these are your qualities, right? These are your things that guide the overall presentation and kind of expressed behavior of your system in a way. So I thought you all did a pretty decent job at this. So well done. And then functionals, these are going to be our measurable requirements, right? So let's talk about some of these. One of the key things with requirements that I noticed is that they have to be full sentences. Okay, so things like having a system that is easy to maintain and operate with user-friendly and clean design. Okay, so there's a lot to unpack here. This one we could probably split up into multiple requirements. Easy to maintain, easy to operate are two different concepts, right? So we would want to split these up. And then we might want to talk about what maintenance is. Maybe we're following a particular design pattern, or we are providing a nice clean or a nice API interface or something like that to go back and do maintenance. User-friendly with a clean design. So that goes with operation, right? Easy to operate is a good one. We should probably give it a little bit more detail about what easy to operate or user-friendly means, right? So the interface meets accessibility standards, or all objects are presented on the screen with a reasonable resolution or something like that. And resolution being obviously the size, right? So definitely good. But again, typically these are going to be a full technical sentence. So the system shall be easy to maintain. The system shall be accessibility ready or something like that. And I'm using the word shall. That's very common in requirements engineering language. Handling both mobile and web platform. Again, goes back to the full sentence thing. Our application shall present a mobile interface and a web interface. Needs to have a quick search time. So again, definitely a very good NFR, but we should rewrite it so that it's measurable, so that it's a lot clearer. So the search time must respond within X seconds, for instance, and X being something that you may want to fill in, or within a reasonable amount of time. Okay, so definitely a good start. The ones I wanted to highlight here, so a couple of the functional requirements, search function, that doesn't tell the engineer anything. We need to make that a full sentence. There shall be a search function that retrieves results for this particular feature, right? We shall be able to search for tools. We shall be able to search for past purchases. So definitely good initial stab at this. Um, I definitely think you all get the concept, which is good. So if we go to formalize it later on, and I'll have you add some requirements to your project for one of your two next assignments. I haven't quite decided yet if I want to inflict that on you already or not, but I'll give you some more guidelines of what to follow for this. But definitely a good start. Anybody have any questions for this little in-class assignment? Because it was a nice little check to see how we're all doing with this. So I'll say more likely than not, though. So you did follow those high level guidelines that I gave you. So they're pretty clear, which is good, right? There is not a lot of duplication internal to the teams that talked, so I liked that definitely. Um, Overall, definitely a good initial start here. But if we're good on that, we can start talking about where we take these next. So, blank screen. Thought there's an image here. What we're going to get at today is something that the cynic in me is going to call controversial for a real world engineer. Absolutely required if you're going an analyst route. Developers may or may not use these. It is highly recommended to understand them. But we're going to start talking about UML and UML diagramming. And I want to caveat this with this is something that if you continue in a software engineering path, right, maybe take further SE classes down the line, this is going to be hammered into you over and over and over again, that this is the most important thing you will do. I said those requirements already, right? But what you may find is that in industry, this is not used as often. Okay, so we're going through modeling procedures here. We're going to create class diagrams, state diagrams, activity diagrams. So basically all of these different types of models that will help you structure your system and help you understand what it is. Anybody have an idea that is in chat here why I'm saying that it's a good activity, but it's not used as often in practice as it should be? I wait for an answer here. Let me pop ahead. So we've got diagrams that look kind of like this. So we'll get to this aspect in a few. Then at the top there's a use case diagram. On the bottom is a sequence diagram, or an interaction diagram. They look pretty similar. I forgot to read the box there. And we have state diagrams, component diagrams. These are all things which we tell you you should be doing and you should understand. But why might they not be used as often? Anybody? Any guesses are good guesses. Difficult to learn. That's a good guess. So, let's talk about that for a sec. This is extra effort that we have to go through to learn something, right? We're teaching you how to code. We're teaching you how to identify runtimes and complexities, data structures, different algorithm types, right? This is one other thing to do. And understanding the syntax of the model could be difficult. Interestingly, this is intended to be a simplifying procedure. So when we talk about UML diagrams, these are actually great for communication purposes. So very quickly showing somebody who is not a developer what the project is. So that's definitely a good guess. It is something else that you have to learn. The thing with UML is that unless if you are using a formal tool where you're taking your models and actually doing things with them, like you're generating code or you're generating documentation or anything where the model's being parsed, you can actually, and if you're a UML enthusiast watching the stream, not in the class, you're going to cringe at this. You don't have to follow the formal syntax perfectly. Um, my advisor heard me saying that, she would probably kill me. But the point is getting the intent of the model to another person. And again, if you're using these models in a formal technical setting for tools, then you have to follow the syntax, otherwise the tools don't work. But if you're using this as a visual tool for other people, then this is a great way to very quickly describe features and aspects of your system. So the answer that I'm trying to get you all to think about is that this is extra effort for people to go through. You have done the design decisions, right? You've talked about the features. Um, you've written down your requirements, right? You make that massive SRS, or you go agile, you do user stories or things of that nature. You have your system spec'd out. This is something else that you now have to do on top of everything that you've already done. And a lot of it is redundant. So the notion, at least in industry currently, at least what I've found, is that UML is extra effort for little gain. However, these models actually are great to, again, simplify and communicate. They're great for demonstrating what features should be doing, how interactions play, what the flow of your system should be. So things that are really hard to kind of tease out with English written like prose requirements, if you see it visually, then you actually may detect other things going on. And they can also be used later on for verification, validation, things of that nature. The other aspect too, before I go into, the meat of this, if you have to go back in your process at all, right, you have to go back and update your requirements, talk to your customer, right, all those things we talked about with our software processes, you also have to update your models, right? So I go through, I update my requirements, I do that change configuration that we talked about last time. We have to do the same thing for every model that is tied to a requirement, for instance. So it's effort, but it should be effort that's well worth it. And again, that's kind of why I'm trying to caveat this, that it is something that academia is a little bit, it's always ahead of where industry is in terms of research and all that. UML's been around forever. It is really finally starting to become more commonplace, at least I think in industry, but there's a lot of places that don't really like it, I guess. So just be aware of that as we go. So we have different types of UML diagrams. And I should also mention too that UML is not the end-all be-all of modeling languages. There are other types as well. UML just tends to be more commonly known. All right. So what do we care about here? We want to visualize our systems, and we want to visualize the various pieces of it. How do they interact with each other? How do they send data between each other? Right? What are the activity sequences that it's going through? So if you start at a login screen, does it then go to your account page, or does it talk to the database, do a lot of verification of your data, SQL injection, protection, go through all your security stuff, and then go to the account page? Do we just present the home page, right? So how does your system flow? And this is something where if it's visualized, you can see very quickly what you have to do. Then you go to your requirements and you figure out the nuances of how to program those things. Okay, so that goes with visualizing, it goes with specifying. So again, higher level than requirements, but a nice way to really tease out those things that are hard to write out in formal language. Then constructing and documenting, these are also nice documentation tools. Models are used for communication, like I said, where communication is talking to your analysts, talking to your managers and your customers and your clients about how your system is put together. But it also can be used for auditing purposes down the line. Or you can have a model and you can actually test the model to make sure that your system is following this particular state flow, for instance. So we have many reasons why we would be doing this. not just extra work for you, even though it may seem like it at times. So we have two main categories here. So we have structural and behavioral models. And there are a ton of subcategories for each of those. But structural is going to be the static side. All right, so when we think of structural, we think of how it's put together. If you did any like class diagrams in your Java class where you specify classes, attributes, methods, things of that nature, that's the more structural. And there's other types of diagrams in there as well. And then behavioral, again, this deals with behavior, meaning what is the system doing, right? What types of activities are being expressed? What's changing at runtime? So again, the dynamic aspect, the behavioral aspect, what is the thing doing after you code it up? Alrighty, so I kind of gave you the quick preview as I was skimming through. I'm curious if you know what a system actually is. So I keep talking about system and product and software package and screaming infant. Seriously, 10 o'clock, I swear to God. It's the time. 1 second. What is the system? I'll be right back in one moment. Alright, what's the system? It's the time to go play outside or go for a nap. Number of things working together to achieve a common task. Absolutely. So, when we talk about a system, it's everything that we have to deal with pertaining to your product, right? So your system here is going to be the code. It's going to be the hardware that that code runs on. It's going to be maybe the different versions of the code, different packages that you've incorporated. Basically anything that, again, the great answer, achieves a common task. Now, a system, it depends on your boundary, but we might be talking to the environment, right? So a system will live in the real world, whether it's a component in a car, whether it is a API for a website, right? You're going to have things that are not necessarily in your control that you have to deal with. So people using your system incorrectly, that's one thing you have to plan for. Other systems that may impact your system that you've put out, or the physical world. This is one that is so hard to plan for. And where these models come into play is we're trying to constrain our system so that we can handle the external side of things. So, physical world, great example. You're making an autonomous car, and it works great when you test it in the summer. Then winter comes along, and you have snow or fog blocking your camera. Well, how does your car drive? Obviously, it has to keep driving, otherwise it's not going to be very autonomous. We're going to rely on other sensors in our system, but we're going to have specifications and models and diagrams that actually tell us, in this example, how do we swap from camera to radar? Or how do we rely on GPS instead of a localized, discovery to figure out where we are in the real world? So, good answer. This is what a system is. The interface, this is how we talk to the real world. So interface has a very particular meaning here as well. It could be how we format our data. It could be what protocols we use to send it, what sensors we are using to understand our environment. These are all specified in our models here. All right, so let's actually look at some of the different types of models we have here. Now, UML is a standard, so this is a unified modeling language, so that's what the acronym stands for. It is versions, so you may get different UML versions as you go through your career. So syntax may change slightly depending on what version you're at. But here's our top two categories, so structural and behavioral. Structural. Here's that class diagram, which you may or may not have seen so far. This is the one that I would expect you to probably have at least some knowledge of. If you don't, I mean, we're going to talk about it here anyway. I'm just kind of thinking you may have seen that. So we have class diagram. We have our deployment diagrams. This is how we actually put our software on hardware, how we deploy things. Now, we'll talk about some of these in more detail as well. But again, these are the more static, right? These don't change. This is specifying the structure of the program. Behavior, this is where we start talking about what the system is actually doing, right? So use cases are where we're really going to start. Um, this is where we specify what things will our system be doing, who is interacting with those things. When I say things, those are basically tiny little activities or tiny little cases. We have our state machines. What are the different states that your system can be in, and how do they go from one state to another safely? And when I say safely, there's always a risk that when your system transitions from one state to another, that bad things can happen to it. Maybe data gets corrupted along the way. Maybe it goes into a state that you were not expecting it to be in because the environment expressed a certain, you know, configuration. When I say configuration of environment, that's like the weather is in snowy state. This is the developer and me thinking and turning the real world into a structure. Um, but you develop your widget for sunny skies, and then you have to deal with snow or fog or rain. These are different states. So these are all behavioral things. These are dynamic things that will exhibit change in your system. And then we have all these other ones here too. But basically, I just wanted to give you a nice little high-level delineation of what these different diagrams are that you're going to be inflicted with. Okay, so first and foremost, structural diagrams. Our class diagram is going to show all of the classes that you have. It's not limited to Java. For instance, you can do a class diagram for any language that has really the object-oriented notation where we have the notion of classes. Okay, do we have classes in pure and CC? No, but we have structures, and we could kind of coerce them into a class diagram. So it's the Java class is not the end all be all to a class diagram. We can do this for Python. We can do this for PHP, C++, C Sharp, right? Any language where we have an object that has a bunch of attributes, that has interfaces, that has relationships we can make a class diagram for. Again, it's a model standard. It's not a language-specific standard. We also have interface diagrams. So this is going to be effectively a subset where we talk about what operations the class can perform. So what are the interfaces, right? These are going to be similar to the methods that you have in your class diagram. We have object diagrams, where these are going to be expressed class diagrams. So let's instantiate things. So what are the objects that we actually have? What are their relationships? How do things all kind of work together? And again, structurally, what are we actually building? We have component diagrams. The one thing that you may notice too is there's actually going to be some overlap in these as well. For instance, when we talk about use case diagrams in a moment, and then we talk about activity diagrams, your use cases actually will populate the activity diagrams. So there's overlap. And when we say things like overlap, that means if something changes here, it has to change here. Otherwise, you have an inconsistency, then your verification and validation process will fail. So extra effort, but generally worthwhile. What else do we have? So we have component diagrams. So these are going to be the actual components that we have. And I've got an example down the line here where I'll talk about these in a little bit more detail. The syntax that you can see is a little bit different maybe than your standard class diagram, and I don't have a good class diagram picture in here, I'm realizing. Let me ask while I have you all here, you all have seen class diagrams before, right? And if not, that's absolutely fine too. It's pulling up a quick image search. So this would be like a class diagram where you have your various classes of objects. Okay, good. And then what are the relationships between them, right? So you have attributes, you have methods, may have slightly different syntax between them, but that's good. So you have seen these. At least one of you has seen these. All right, so we have component diagrams. We have deployment diagrams. I mentioned this is going to be how we actually take our software and deploy it. So these are going to be nodes that they may exist at runtime. So they're being, again, deployed. These are going to become physical running entities. We may have a relationship to our component diagram. So again, we have a lot of overlap here. Then on the other side, to do a little high level here, we have our use case diagrams, which we're going to start talking about here momentarily. This is where we look at things at the goal level or the feature level, right? So these are very high level bubbles that say what is one unique use case. So user login or log in the user, the use case. That has a lot of sub activities associated with it, right? But at a high level, we just care that we want to log into the system. We also care about who is associated with that. And when I say who, I'm talking about the actors. An actor can be a person, an actor can be a system that is tied in with this particular use case. So we'll get to that. Interaction diagrams, we're interested in how basically we have an interaction. These are all basically self-defined in their name. You know, what is talking to what, in what order are things happening? So how is data moving from one point to another at what time? Yeah, so we'll be getting into all of these, honestly. So let me show or talk about this kind of briefly here, because we're going to get into use case diagramming here. I'll do a little example of this and probably an activity diagram if we have time. We're going to go into this in a lot more detail in the next set of slides too. But just at a high level, we have our actors. So our little stick figures are our actors. We have a boundary here. So this is the boundary of this particular use case diagram. The bubbles inside are use cases, and you can see that the actual use case is very, very terse. Okay, so it's very short. Generally, these are like verb noun types of constructs. Make purchase, complete checkout, login, logout, update order. So basically, these are all kind of very high level activities that we would have. And then we have relationships in here as well. So which actor is associated with that use case? And if you look at a model like this, you can very quickly see who is basically participating in this activity, right? If you try to figure out which users, which systems are interacting with, say, a make purchase activity, it's a lot easier to see in a use case diagram versus your requirement spec. Now you will define that in your spec, right? So we have to handle customer input, we have to sanitize so and so, right? So all of these things we have to do to make a purchase. But here we have a nice, very quick high level view. We have associations as well. So we have includes, so we have extends, we have generalizations. Not sure if you talked about that in your Java class, but basically we are including functionality from other use cases, or we're extending other use cases with new features, or we're generalizing and specializing use cases from like a template kind of a thing. So these typical object-oriented notions that we have apply here. And then we kind of can maybe see how, if we're making a purchase, well, we also need the functionality from view items, right? So if this is, say, a class or a header, or whatever language you're using, we're going to include the functionality to view items in here. That way we don't have to code it up twice. We just say include view items.h or import org dot online shopping system dot view items, however you're going to import your Java class or your Python module. So definitely useful to have. Here we have an interaction diagram. So this is one of our use scenarios, again, behavioral. So we have basically a person talking on a phone with another person. We have a caller, we have an exchange, we have a receiver, and we have talk. So here's different, basically, actors, or they're going to be objects. It just depends what the type is here. But this little dotted line is basically saying here is throughout the time of this interaction what my particular interaction in the system is. So if I want to call somebody, I have to take the phone off the hook, and we're going back to the olden days when you actually had to pull a phone off rather than hit the power button. But pick up the phone, the exchanger is going to send you a dial tone. You are going to then dial the number of your best friend, of your mom, of your grandparent that you need to call. And then the exchanger is going to take that number, parse it out, send a ringtone to the receiver. Then the receiver, phone's currently on the hook, person has to take it off the hook. We're going to go back to the exchanger, and then we're going to have this two-way voice communication happen. So again, if you can take any process and decompose it into any of these diagrams. The interaction diagram tells you at which point things are supposed to happen in a particular sequence. Maybe you need to have a very rigorous state machine defined for a particular activity. And using an interaction diagram here, you can see who is responsible for what at what given time of the process. And then we'd also have a state diagram associated with that showing the different states. I'm going to assume this is a little bit further along for some of you. Have any of you ever done a state diagram before? I don't think I did this until I was a senior when I was an undergrad, so that's probably a little bit ahead of things yet, unless you talked about it in your Java class. This is kind of getting towards like the formal automata types of discussions in a way. Here it's a little bit more generalized though. Anybody here ever do a state diagram? Never done it. Okay, good. You get to learn it. So, a state diagram. Nope, 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 nope. Cool. Hey, something you haven't done before. Fun. So a state diagram, you're going to list out all of the unique states of your system. And the difference between this and, I clicked something, so the prior one, here we have some, like a different view at it. We don't necessarily have unique states here, but we have what the interactions between entities are. And you can kind of tease out what state we're in. And when I say state, this is basically like, if we're using this phone example, the initial state would be, we haven't even started to call anybody yet. So both phones are on the hook. The phone exchange has not been contacted yet. Everything is in an initialized base state. Then you transition to state one, right? I am calling somebody else. So in this state, I have picked up the phone. I now have my dial tone because I'm in the state. And now I start punching in numbers. This sends me over to state two, where the exchange has to parse out what I've sent, figure out where it has to go, and then send it to the next state, which would be like a receive call. If those of you that are doing games for your term project, you're going to have different states as well, right? You might have the base state where you're initializing everything in your game. State one's going to be main menu, where the user is just sitting there waiting to pick new game, options, quit, whatever, right? State two might be new game, state three might be load game, state four might be, level one, or however you want to go into this. But this is basically showing how do you move from state to state, right? So if I'm sitting here in main menu and I click options, so the trigger, right? This is called a trigger or a guard or constraint, just depends on how you want to say it. But clicking the options button sends you to state two. And then I sit in state two. So we have a little self transition where basically I'm looping in here until I get another trigger, right? So user hits escape, goes back to state one, or user hits sound options and goes to the sound menu. So you can decompose this into a very, very complicated diagram. And that's one thing that I should mention here too, is that these diagrams can get super complicated. For instance, let me pull up I used to have a great spaghetti code mess of a class diagram to show off. But here we have a class diagram, hopefully. Yeah, which is, honestly, this isn't too bad in terms of class diagrams, but these can become just absolutely massive and not just, here like a class type of thing. Well, this is actually a meta model, but it's very similar to a class diagram. But think of how complicated your systems are. And if you just throw everything into one model, it's going to become a huge spaghetti mess of lines and just impossible to read, right? So, again, if you're thinking of doing like a game or a web app and you're doing a state diagram, it's not just going to be three little states, it's going to be a ton of things you have to deal with. And so where I'm going with that is generally we might break these up into like submodels. So state one is actually another diagram or something like that. Or we might simplify things to try and show as much behavior as we have here. Okay, so this is the high level of things. So if we're going to actually develop these diagrams, and you don't necessarily have to do all of them, you might start with well, and actually, I should actually talk about the development process, otherwise this doesn't make much sense. So you start off generally with your requirements, right? So we did that the last several times. Then we're going to take our requirements and figure out what the high-level use cases are out of those. So that's where we talk about a use case diagram, right? I know requirements 1 through 200 talk about the login system. So I'm going to have a bubble that says login. Those 200 recs would be tied to this use case. With that use case, then we tease out, again, who is associated with which use case. And that will help inform our development. After we create our use case, we might develop our class diagrams. So what is the structure of our system, right? What are the classes that we have? What are the attributes? What are the methods? What is this system at a closer to an implementation level? We may instantiate it with an object diagram. So if we have a class that is a dog class, so that's the standard class diagram example, right? You have an animal where a dog is a animal, a cat is a animal, for instance. What is the dog's name? What breed is it? How tall is it, right? What color is it? So that's when you get the object diagram, you start specifying the instantiated objects in your system. After that, how are you going to be using this thing? So what are the interactions? What are the sequences that we may have to define? If we talk about collaboration diagrams, we're going to talk about, again, who is associating with what. And I don't have a picture of this, I'm sorry, but when we have like an object diagram structure, who's sending messages where? And again, I'm kind of saying this at a high level. There's a lot of overlap, but we're basically refining our models. So like we have a high level class diagram, object model would be that instantiation. So we have refined it, we've instantiated it. And then we can see if there are any problems with our class, right? If we have an animal class and we have a dog, what sound does it make? We might need to know if it barks, if it talks in English, right? It just kind of depends on what we're looking for. And when I say bark or woof or talk, maybe it's for a game or a simulation you're making. You need to know what to put on the screen. Or if you're writing one of those super cool animal language parsers where people think they know what dogs are saying, you need to be able to parse that out as well. All right, so we have our high level, we have our classes, we have our interactions. I'm going to say interactions is kind of a grouping here. Then we're going to generalize some more. So what are the states of our system, right? State 1, state 2, state 3. How do we go between states? What constraints do we have between those? And then we're going to refine even further with our other diagrams, which actually go into the implementation, right? Here's a component diagram showing if we're at a particular state, how are we getting to a to an internal state? right? We have components where these have a very particular syntax to them, but basically they're going to be what is a, here we have a safety inspection, or we might have a login module, login component, right? What does this comprise? We'll be getting into all of this kind of stuff, so don't worry if this is a little high level right now. Point of all of this, really, is that we are just trying to get to a place where we can have a system where we can describe the various aspects to other people, right? So if you're the systems analyst, you might not be the developer. You might be more concerned with specifying how a user will be interacting with the system. So a state diagram or a sequence diagram will be your language rather than 500 requirements. So let's do a little example here. And I've got a couple of them that I can go through. So first and foremost, let's talk about my little fun baby here that I've been playing with, my term project. So I've got this very ugly tile map. I've got some debug text that I got in here earlier today. So I've got an enemy right here that I'm circling around. My guy's kind of slow or very quickly zooming around the map. It's a Pygame window, and it's a tile map. So you can see that basically every cell here is a tile out of a sprite sheet. And again, let me, no, not this one. Over here, here's my tile map. So the map is generated by all of these tiles, basically. And it's actually clustered up here. Very ugly. I will probably switch the tiles to something a little prettier later on. But this is where I'm at right now. Okay, so I have a person moving around and I have a map. And I want to focus on making an interesting environment for the player to see. Okay, so we have this. And how can I model that as a use case diagram? So I have a particular need to describe the map generator. Take the, and I'm going to talk about this in terms of a game, take it and apply it to your project, right? If you're doing a web app, you have a particular unique feature you want to describe. If you're doing, there's one of you that are doing the RFID disc golf finder, right? What is one of your unique use cases to deal with? Well, that might be talk to the RFID chip on the frisbee, right? Or sorry, the disc. Or if you're, I'm trying to think of what else you guys are doing. One of you is doing a smart mirror. One of the particular use cases is going to be changing the display. What are all the particular use cases that comprise that task? So you all get to now see how horrible my writing is, especially in terms of I've got a tablet here, which is going to make this even worse. But let's draw out a use case diagram. Okay, so what do I care about here? Come on, pen. There we go. No, stop going to the other screen. Come on. Over here. Is this? Sorry. My mouse keeps going to the other screen. So. What the hell? There we go. Use. Really? Wow. What's going on here? Sorry. Stop drawing. What are you doing? Stop drawing. This is hilarious. I did this earlier just to make sure it worked. All right. Use. Oh my god, this is awful. I am so sorry. I don't know if my streaming software is messing with my drawboard here. Let's just do this. So map generator is what I'm trying to write out. So I have start game. Like the fact that my mouse is just jumping everywhere on this thing is incredible right now. All right, I have load game. Let's make them a little bit smaller. I have init state. I'm just starting to abbreviate now because this is just going all over the place. Gen level. All right, so let's talk about these four use cases that I have here. So when I start my game, this is when I initialize everything. When I load a game, I might have written it out to disk. If I want to initialize the state of my game, this is where maybe I generate all my constructs that I have, user attributes, maybe enemies for the level, things of that nature. Sorry, this is generate next level. Next. Now we can't see that. Generate next. Okay, beautiful. All right, so this is my use case diagram for handling map generation. And that's supposed to be a square. All right, what happens when I start my game? Well, I have a blank slate. If I want to load an existing game, I might be extending start game. Wow. Wow, wow, wow. I practiced this just so that you're all aware. I do know how to write extend. So this says extend. Doot, 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 doot. And what this is saying is that whenever I load a game, I'm going to extend the start game functionality. And what that means is that I'm going to take all of my initialization code and I'm going to extend it with pulling whatever I have off the disk. Okay, so I'm going to have a game state. Both codes going to use the same code base, except for loading my game, I'm going to be extending what was already there. All right, initialize state. Here I want to include, and I drew things too close together, and now things are freezing on me because that's just how today's going. Wow, in cloud. This has got to be painful to watch. Include. Doot, 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 doot. All right. So I'm just showing you a little bit of extended use case syntax here. So if I want to generate a level, I need to include an initializer activity or an initializer use case. So let's initialize everything. Let's initialize the map, initialize the enemies, initialize the player. And if I'm going to the next level, I probably have code for how I generate a dungeon or how I, instantiate something for the next iteration. All right, so we have these four use cases. I don't have everybody on my screen, so hopefully this makes sense. Now, what do I have as part of the as part of the actor? So I'm gonna have a person, right? So this is gonna be my player character. Beautiful stick figure. I am not an artist. Give him a happy face. It's got a unibrow. The happy face is not part of the UML syntax, but I want to start the game. I want to load a game. Okay. The player character, the user, I'm not going to be the one initializing the state. Okay, my game engine will be. So I have an engine. That's right, engine. Are we at 2 more minutes? Engine. This is an actor. And you're a box, since you're not a person. You will initialize the state. And I may also have some interaction with starting the game. Let's not have a touch load game, otherwise you guys may... we'll have a load game as well. You can kind of see how these very quickly get kind of out of visibility, even with my poor penmanship here. So our game engine is going to be responsible for actually creating the game, for actually loading things, for initializing the state. Next to level generation, I might have a generator. This is called gen for short. This is an actor, so that we know. Doot, 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 doot. You're in a box. You're going to generate the next level. Okay. I would move the player character over here so that these lines don't overlap. But this map generator is going to run Since I'm doing a roguelike, it might generate a cellular automata, or it might just do a recursive carving of my dungeon, or I'm going to place all the trees all over the place, right? So I have a separate subsystem that interacts with that. The game engine may not interact with that, so I don't have a connection there. The whole purpose of this activity is to show who is interacting with which use case. And next time when we talk about going through and specifying what each use case means, you're going to have basically a template to fill out. Which requirements does this use case tie to? What is its title, its ID, description, things of that nature. Okay, everything makes sense from today. Hopefully. We have officially hit 1050. I must have hit a button on my little... I've got one of these guys for drawing. I must hit a button that like screwed with the sensitivity while I was moving it around. But if we are all good, I will see you all Monday. I'll probably have a nice fresh homework assignment for you on Monday as well, would be my guess. But other than that, we'll be delving into use case diagrams on Monday. Have a wonderful weekend, and I will see you then. Bye, everybody. Meetings due Sunday. Yes, check in your meeting minutes by Sunday nights. And again, I've got that calendar entry in Blackboard if you haven't noticed it yet. I think you can import it into your personal calendars too. All right. Have a great weekend, everybody.